Series circuit? Multiplier. Alright, so we're going to go to our next, so we'll open up our worksheets here. Start taking a look at the next one.
Class, just to let you know, last time Kurt was filmed, and we have it, we have the film, he screwed up Ohm's law. So we can show you that, so just know that.
Is that on the YouTube now?
Yes, we have it.
This way we have evidence if he's leading us in the wrong
Yeah, the
direction.
fact that he's being filmed now, this lecture is a bust.
Don't get, don't like being on camera.
Smile.
It was pretty funny.
That 37 Kurt?
What's that?
437 or
137. 136, 137.
433?
Oh, the worksheet, wait, I lost the page number. What is it? 433. Give you a little warning, I'm low. I don't know, the rate we went the outside, I got like a killer headache here, so I'll probably be a little bit slow, so might make a few mistakes here, but get these twice every year. All right, so so we have a series circuit again, and a lot of times when we're doing any troubleshooting or anything like that, the only thing that we really need to know are voltages. So you can see now that we're only looking for two items. We're just looking for what's the resistance of the component and what the voltage is. So we don't even need to use Ohm's law on this. And since we talked about yesterday is that we said the largest resistor is going to do what with the voltage? It's going to drop the most amount of voltage. Okay? Well, that kind of goes true for any size of the resistor. It's all going to be proportional to the size of the resistor against the total resistance. So they're all going to drop proportionally. So the smallest one's going to drop the least, the largest one's going to drop the most, and then anything in between will drop something in between there. So what we can do is on page 136, and this is a formula that we use all the time, there's our voltage divider formula. So if we want to find out any voltage on any given resistor without having to find out what our current is and all that, we can use our formula, so for example, find the voltage of a particular resistor. We can take our resistance of our resistor and divide it by our total resistance, and then multiply it by our voltage source.
What page was that on?
136. Yep. So what we're going to do is the next few worksheets is that we're just going to find just the voltages without even determining what the current is. So first thing that we need to do is come up with our resistance total. So what would be my resistance total of this circuit? 3 kilo ohm. And before we did that, we should have done what? What should have been our first step? Yeah, draw our current paths and polarities. So we know that my current's going to go always is going from negative to positive. My current's going to start to flow this way. And now, since we're going to start to talk about test points, you're going to see why the importance of having our polarity across our resistors are. So we got to make sure that, you know, this side of the resistor is always going to be more negative than this side. This side is going to be more positive. Because every time it has that opposition to current, the electrons are going to build up on that side of that resistor, and the protons on the other side. And back to our source. All right, so what we want to do is find the voltage of, again, I always like to follow the current path, not according to the labels that they labeled the resistors, but according to the current path. So let's find the voltage drop across R3. Oh, we should fill in, let's fill in our resistors here. So to find our voltage of R3, basically what we're going to do is we're going to take our...
They're all 1.0 kiloohms.
Oh, are they?
Yep.
I told you I'm not... I really get hit up on these headaches, and I really...
I know what you mean.
So, so what we're going to do is we're going to take the value of our resistor, our 1K for R3, and we're going to divide it by our total resistance of 3 kiloohms, and we're going to multiply it by our voltage source, which is 24 volts. And that will equal our voltage across R3. So if we take our 1 kiloohm divided by 3 kiloohms, and then multiply it by 24, what do we end up getting?
8 volts.
8 volts?
Yep.
So then if we look at R2 then, since it's got the same value of resistor, what's that one going to drop for voltage? 8 volts. And then the same thing with R1. So since they're all 1 kiloohms, they're all going to proportionally drop the same amount. And then if we did our Kirchhoff's voltage law and added up all the sums of all our voltage drops, we should equal our source voltage, and do we?
Yes.
Yes, we do. All right, so then our next step then is that we're going to start looking at our test points. So now when we're doing test points, a lot of times you'll see on your schematics there's going to be a little section in here where they have test points. And then a lot of times they'll tell you what the voltages are, so that you can troubleshoot it. And you should be, you know, they'll tell you the, you know, for example, at DAG, it's going to be at some certain voltage. Well, then we need to know how to hook up our meter leads up to it, so that we can verify that that voltage is there. So when we're looking at test points, our first letter is going to represent what?
Test point A.
Yep, test point A. What color lead do I put on there?
Red.
My red one. This is going to be my polarity. And that's going to be my red lead. The second one is going to be my reference point. And that's going to be where my black lead goes. And so then if we did that, we'll assume my blue pin is my black lead. So they want to know what the test point voltages of DAG is. So where does my red lead go? A. And so I just put my red lead there, my black lead goes where? G. G, which is the same as my reference point. It's ground. So now to determine what that voltage is all I have to do is I just have to algebraically add up the sum from my red lead to my black lead.
Yep.
Once I identify where my black lead is, this one never moves. You never move the black lead. You always move the red one. And then as you go around, so for example, we'll start out with A. When we start looking at the first polarity that we run into. So here it's going to be a positive 8 volts. Then I'm going to keep on going around, and I'm going to add another positive 8 volts. So I'm up to what now?
16.
Positive 16 volts. And then now I'm back to my black lead and I'm done.
You go the other way too?
Yep, I'm going to do that too. So what my answer should be now is I should have a positive 16 volts. Okay, and here's where I get a lot of people get a lot of wrong answers. When I'm talking about a voltage drop, there's no polarity. I'm not indicating a polarity on for my answer. When I am talking about test points, I do have to make sure I have a polarity. I have to either identify whether it's positive or negative. If it's positive, I have to put that positive sign in there. If it's negative, I have to put that negative sign in there. So I need to make sure that there's polarity on it. Okay? So like Josh was saying, we can go either way too. It doesn't really matter. So if for example, I'm going to start out here on a positive 8 plus a positive 8, and I got a positive 16. I can also go the other way. You can start out at A here and go this way. Here I have a positive 24 volts plus a negative 8 volts equals what?
16.
Positive 16 volts. So it doesn't matter which way I go, my answer is always going to be the same. And so if I had put my voltmeter on here and I went from here to here, I would measure a positive 16 volts. Okay? Now all these test points are all outputs. These might be going to another circuit. Okay? So they're either used for typically used for troubleshooting, and then also it's because it's going to an output to another circuit. So they can be kind of used for two things. All right, so then my next one is, what is that, BVG?
Yep.
Okay, so where does my red lead go?
B.
On B. And my black lead goes where?
On ground.
Stays on ground. Then all I have to do is just bring my red lead down. So I'm going to go, first sign I see is positive, look at my voltage drop, and up to ground. So I get a positive what? Positive 8 volts. And then VCG, then I'm going to get, my red lead goes where?
On the C.
On the C, black lead goes where?
On the ground.
On the ground. And then what am I going to get for voltage?
Negative 8 volts.
A negative 8 volts. And again, it doesn't matter which way we go, we can even prove it out, that even if I go from C and go the long way around, I'm going to have a negative 24 volts plus a positive 8 volts, brings me down to a negative 16 volts. Come back around and add another positive 8 volts, will give me my negative 8 volts. So it doesn't matter which direction you go, you just have to watch your polarities and your signs. So for example, if I wanted, if I wanted 8 volts going into, a positive 8 volts going into my next circuit, all I would need to know is that I just need to come out of my test point B and my G, and I would get a positive 8 volts coming out of there. Now, on our test points, if it only shows it as being one letter, one test point on there, that one letter is always going to be my polarity. That's going to be my red lead. And if there's nothing after that one, it's still going to refer to my reference point, but that's always going to be my ground, my reference point. Okay? So for example, if I said what's my voltage at VA, I put my red lead where? On A. My black lead's going to go where?
Ground.
On the ground. And then I just go back around. A positive 8 plus a positive 8 would give me my positive 16 volts. So VA and VAG are one and the same in this particular case. So what would I get for voltage then from so what would be my voltage from DCB? What would that equal? So what would be my voltage at DCB?
Negative 16.
Okay? So my red lead goes where?
On C.
Okay, and my black lead goes where?
On B.
On B. Then and it doesn't matter which round I go. I'm going to just start out here. First sign I see is negative 8 plus another negative 8 gives me negative 16 volts. So if I needed something with a negative 16 volts going into my circuit, I know that I can go off my test points C to B. Okay? Now, since I have everything all drawn up, sometimes what we like to do is, and we're going to really talk about it when we get into chapter 6, is what we call straight lining. So sometimes it's a little easier if we redraw up our circuits. Because sometimes our circuits are very complex circuits. Maybe I'll start printing out print out some schematics here. So for example, the straight line, what we want to do is keep our power source on the left-hand side. So I'm always going to put my power source on the left-hand side. Then I'm going to come down, and then all my components are on the right-hand side, and they're all going to be drawn vertically. And then I have to make sure that I get all my test points and my values of my resistors in the right location, so I know that this is R3, R2, R1. This one was 1 kilo ohm. I know that this is going to be test point C. This one's going to be test point G, which is also my ground. Test point B, and test point A. And I know that I got 24 volt source. Again, I want to draw my current paths and polarities after I do my straight lining. Get my polarities in there. That up and down. Okay? So sometimes it's a little easier to see the circuits if we straight line it. So we like to straight line all our circuits when we're analyzing circuits and trying to find out what's going on. So that means that my power source is on the left-hand side, and all my components are on the right-hand side. And then now I can analyze, so if I want to find out what all my test points are, reference to ground, I know that test point A, and I can just kind of go back down, which way my voltage drops. So I'm just going to put so I'm just trying to, if I'm not indicating if there's nothing that's telling me what the test points are, but I want to know what they are myself, I always just put my black lead on my ground, put my red lead on A, and add them up. And I'm going to go positive 8 plus positive 8 gives me my positive 16 volts coming out of test point A. Then my next one is going to be B. And again, I'm going to just have a positive 8 volts. And then my test point B is going to be my positive 8 volts. Then my next one then is going to be G. So test point G, my black lead goes on G, my red lead goes on G, and what would I measure? 0. And like I always said, that test points always need polarity, and that holds true when we're at our reference point too. So we always want to put polarity, but all we do is we just say it's either plus or minus 0 volts. So all test points, no matter even if it's 0, get polarities. And then my next one then is going to be C. I still keep my black lead on my ground, my red lead on C, and then I just bring my red lead up to my black lead. First sign C is negative 8 volts. So those are all my voltages. So now these on, you can kind of see, hey, here's all my outputs. Referencing it to ground. So if I needed a positive 8 volts going to another circuit, I know that I could go from my reference point to test point B and I'd get a positive 8 volts. If I need something negative 8 volts, I'd go from my reference point to test point C and I'd get a negative 8 volts. And those are all outputs going to another circuit. Okay, so what gets, another thing that people get confused on is that now we have our test points, then we have our voltage drops. The ones on the resistors, those are our voltage drops, or our IR drops. Those have no polarity, but those are just the voltages that's going across that resistor. And these are my test points relative to some other point. So if I wanted to know, if I didn't, let's say I had all these test points, so let's say we had, we didn't know what the voltage drop across R2 was, and I want to find out what the voltage drop is that I could go ahead and I could bring my meter leads up to my test point. I know that my reference point is going to be plus or minus 0, and my test point B is at a positive 8 volts. So to determine what that voltage drop is across that component, is I'm just going to take the potential difference, and this is where we use that word potential difference for our voltage, take the potential difference between the 2 points, between my ground and my test point B. And what's my potential difference between ground and B? Yep, now we're looking at it, we're trying to find a voltage drop. Yep, so you're on the right track, but so I'm looking for my IR drop across R2, and I get 8 volts. Okay. Same thing if we didn't know what R1 was, and I want to know what the voltage drop across R1 is, I can put my, and it really doesn't matter my polarity because we're concerned with polarities at this time because it's voltage drop. All we have to do is determine what the potential difference is between the two. So what's my potential difference between my positive 8 volts and positive 16 volts? 8 volts. So then I would know that I'd have an 8 volt drop there. One more thing here. I was just thinking of something else I wanted to. Okay, drawing a blank. We'll see it on the next one. So yeah, so it's always good to go ahead and straight line it because then we can really see what's going on with our circuit. Just thinking about it, I go, oh yeah, I want to make sure I cover that. dang it. I'll come back to it. I'll refresh my memory here again. All right. So any questions on this particular circuit? All right, let's take a look at, yeah.
On 440 here, on the series circuit 2, there's a letter you may sign. When yes is for Y equals VG on 440.
All right, let me pop that one up and take a look at it.
Just leave it up and think about it.
Yeah, okay. Neat. All right. All right, let's take a look.
$438.8.
442.
No, 440.
Oh, there it is. That is, I don't know, I'm looking at my.
So you're asking for Y and B, or voltage DG, you don't even have this point D on there. You don't have A, B, C, and G.
Yeah, but there's no VG.
Huh, D.
Maybe just a misprint.
So we see on here, there are three C.
That's what we got. We got C on there.
It's got a DM. And we do also have a voltage G.
Really, how the heck? Should have came from the same file.
They only have 3 mesh points on here.
Just connect the C together and put D.
File is printed it off. That's weird. Huh. I already know how that can happen. That's great. Good catch there, Josh.
We all make mistakes.
Oh yeah, but that's my first one. Yeah, so make sure you change this one to D then.
Okay, then we're C.
Then yeah.
Cross off the bottom line.
Yeah, just cross the bottom line out.
So I have,
Because we have H.
so I have C, but I don't have D on there. Alright, so yeah, alright, so we'll change this one to. So we'll make that one DCB then. Alright, well let's go ahead and we'll take a look at that one. That's strange, huh? Alright, so first thing we're gonna do then is we're still gonna go ahead and we're gonna draw in our current paths and polarities. We know this is negative, positive. My electrons go from negative to positive. Get my polarities in there. I told you, watch for me today. I'm not.
What's all on
All right, there we go. So I have my negative sign, and this one's wrong too. This is the positive sign.
It's okay, Kurt. We won't give Tom the video footage.
All right. All right. So this one's going to flow from clockwise or counterclockwise. Clockwise this time. So it's going to flow from our negative. This way. Making sure we get our polarities across our resistors. Back up. Filling all the information we know. We know that my voltage, source voltage is going to be my 12 volts. And all my resistors, this resistor is going to be 1 kilo ohm. This one's going to be 2 kilo ohms. And this one's going to be our 1.2 kilo ohm. All right, so what we're going to do on this one here, we're going to straight line it. Oops, I screwed up again. R1 is just 1 kilo ohm. Yeah. Alright, let's see what we've done. Alright, so anyways, we can go ahead and, since you have it on your worksheet, we still can go ahead and straight line while we'll get our projector back up. So we know that my source I'm going to put on the left-hand side. And I'm going to come down and then go up, force myself to go up. And so what I do is I just kind of make myself a vertical line, because when we get into series parallel circuits, it gets to be a little bit more complicated. And then put in our 3 resistors. And R3 was what for a value, for a resistor value? 1 kilo ohm. 1 kilo ohm. And R2 is what? 2 kilo ohms. And R1? 1 kilo ohm. Okay, good. And my ground was here. And that was also test point G. Okay, so this test point here is going to be what? C. This test point is going to be B. And then this one is A. All right, so now even before we even start using our voltage divider formula, what do we know about R2? Yeah, it's going to have twice as much voltage as R1 and R2 is. Okay, so we're always just going to be looking for things that we can use to double check our work as we're analyzing our circuits. So now let's go ahead and figure out what the voltage drop across R1 is. So what would be my voltage drop using the voltage divider formula? What would be my voltage drop across R1?
3 volts.
How many?
3.
3 volts? So no polarity, just my voltage drop across my R1. So then that would have to make R3 how many volts? 3 volts. So then R2 would have to drop how much? 6 volts. So a lot of times we can save ourselves a lot of extra work by just kind of analyzing the circuit. All we have to do is figure out one, and then we can figure out the other 2. And then if we double check our work, do all my voltage drops equal my source voltage? Yes, they do. And my current then, make sure we get our current tabs in there. And that. All right, so now our next step then is that we want to find out what our voltage drops are and our test points are. So my red lead's going to go where for finding the first test point here? Where's my red lead going to go? A. And my black lead's going to go where? G. G. And so I never move my black lead. I just bring my red one down to my black one, and then I algebraically add up my voltage drops as I go along. So I bring my red lead down, the first sign I see is negative 3 volts. So test point A is going to equal what? Negative 3 volts. Okay? And then test point B to G is going to equal what?
Positive
6. Positive 6 volts. And then test point C,
Positive 9.
positive 9. So first sign I see is positive 3. Keep going up. Next sign is positive 6. So that gives me a positive 9 volts.
Can we go over 438?
Sure. So what do I get at test point G then?
0 volts.
0, 0.
Positive, negative, 0 volts.
Yes, plus or minus 0 volts. So don't forget your signs for 0 volts. All test points require clarity. That's why we put in plus or minus 0 volts so that we can keep our rule true. But all test points require clarity, and voltage drops do not require anything. Because you can tell that it doesn't have anything to do with the voltage drop. It depends on where we're referencing our red and black leads. So no polarity on our voltage drops. All right, what would I get from B to A then? So if I go VBA,
Oh,
3 volts. Yeah, so my red lead goes where?
on A.
On B.
B.
And my black lead goes where? A. And I bring my red lead up to my black lead, so first sign I see is positive 6 volts, plus another positive 3 volts, and that gives me a positive 9 volts. Okay? The potential difference between B and A is going to be what? What's the potential differences between B and A?
9 volts.
9 volts, okay? Then when we determine which one is going to be our polarity and which one's our reference point, then that's when we end up with our positive or negative 9. So for example, if I went with, I could have also a test point that's test point AB, and that would equal what? A negative 9 volts. So if I needed something at negative 9 volts, I could just go ahead and put my red lead on A and my black lead on B, and that would give me my negative 9 volts. If I needed something positive, I just have to switch my 2 leads around and get my positive 9 volts. Okay? All right, pretty straightforward. All right. Which one did you want to look at?
438.
438.
Okay. All right, let's take a look at 438, and let's there. A mistake on the worksheet, or you just want to see it?
Yeah, I figured out where my problem was. It was a math thing.
All right, well, here, why don't we just do this while we, so do this one on your own, and then we'll come up with the answers. I'm going to list the answers after I give you a few minutes here. So the first thing you're going to do is draw in your polarities and your curve paths, and then straight line it on a backside of your sheet or on another sheet. Make sure you use your voltage divider formula. Double check your answer with the person next to you.
Yeah, I just figured it out. I sat on that problem for an hour last night and figured it out. And just after I asked him, I'm like, okay, I'm going to re-add the numbers.
Is that where we got right there?